Meter bridge, law of combination of resistors. The property of a conductor to oppose the flow of charges through it is called its resistance. In this experiment, our aim is to verify the laws of resistance in series and parallel. Materials required: a meter bridge, jockey, Lagrange cell, resistance box, galvanometer, key, connecting wires, wire cutter, scale, 2 resistance wires or 2 resistance coils and sandpaper. Procedure: first, make the connections as shown in the circuit diagram. Take a connecting wire and cut it using a wire cutter. Connect one end of the wire to the positive terminal of the Lagrange cell and the other end to terminal A of the meter bridge. Now, take another connecting wire and connect it between the negative terminal of the Lagrange cell and one end of the key. The other end of the key is connected to the terminal B of the meter bridge with another connecting wire. Now introduce the resistance box in the gap G1 of the meter bridge. Then take a resistance wire R1 and connect it in the gap G2 of the meter bridge. Since the resistance of the wire depends on its length, make sure that both ends of the resistance wire just touch on the gap. With other connecting wires, connect the positive terminal of the galvanometer to the central terminal of the meter bridge and negative terminal of the galvanometer to the jockey. Now insert the key and press the jockey near A and then near B. If the galvanometer deflections are in opposite directions, then the connections are correct. Now, press the jockey almost at the middle of the wire on the meter and introduce a suitable resistance R in the resistance box so that the galvanometer shows 0 deflection. Measure the distance L1 from terminal A to the balancing point. Now, interchange the position of the resistance wire and resistance box in gaps G1 and G2. Measure the distance L2 from the terminal B to the balancing point. Then calculate the mean balancing length L. Then calculate unknown resistance using the equation X is equal to L whole divided by 100 minus L into R. Repeat the experiment for different values of R and mean value of the resistance gives the resistance X1 of the wire. After taking the measurements, remove the key and then the resistance wire R1. Now take the new resistance wire R2 and connect it in the gap G2 of the meter bridge. Insert the key and repeat the same steps for finding out the mean resistance of the resistance wire X2. After taking the values, remove the key and then the resistance wire R2. Now take 2 resistance wires R1 and R2 and connect it in series by joining the wires together. Introduce this combination in the gap G2 and resistance box in G1 and vice versa. Insert the key and repeat the experiment for different values of R and calculate the mean resistance XS using the equation XS is equal to L divided by 100 minus L into R. To verify the laws of resistance connected in series, calculate the theoretical value of XS using the equation XS is equal to X1 plus X2. If the experimental and theoretical values of XS are same, then the law of resistance in series is verified. Now, connect the resistance wires R1 and R2 in parallel in the gap G2 and resistance box in G1 and vice versa. Insert the key and repeat the experiment for different values of R and calculate the mean resistance XP using the equation XP is equal to L divided by 100 minus L into R. To verify the laws of resistance connected in parallel, calculate the theoretical value of xp using the equation xp is equal to x1 x2 whole divided by x1 plus x2. If the experimental and theoretical values of xp are the same, then the law of resistance in parallel is verified.